John Gilroy here. In the next 30 minutes, we will take a deep dive into the world of securely deleting data. Hit the music, Manny.
Welcome to the Federal Tech Podcast, where industry leaders share insights on innovation with a focus on reducing cost and improving security for federal technology. If you like the Federal Tech Podcast, please support us by giving us a rating and review on Apple Podcast.
Welcome to the Federal Tech Podcast. My name is John Gilroy, and I will be your moderator. Today, we have Maurice Uanuma, and he is with a company called Blanco Technology Group. And we're going to talk about a new topic for me. This is about, erasing hard drives and making data secure, and what are the processes involved, NIST standards for erasure, why my listeners should even consider it. And before we begin, Maurice, why don't you tell us a little bit about your background, and then we'll just jump right into this whole topic of volumes and erasure and all kinds of issues this brings up.
Yeah, certainly. Hi, John. Thanks for having me. Great to be here. So brief background. So I'm currently the Vice President General Manager for the Americas at Blanco Technology Group. I've been here with the company a little over a year. Most of my background in cybersecurity, previously with security software company Tripwire as VP of Federal and Enterprise. I've also spent time at the Center for Internet Security, focused on cybersecurity standards and best practices, with a background in IT services, as well as a military background. So began my career as a Marine Corps officer following my graduation from the U.S. Naval Academy, served in a variety of infantry and special operations roles before transitioning into the very different world of IT.
Right now, Maurice, I've been up to NIST many times, the Washington, D.C. area, and talked to a lot of people. I certainly have referred to NIST standards over the last 15 years, but never in the last 1,000 interviews have I talked about NIST standards for erasing. It's brand new topic to me. Why is this becoming a trending topic? Why is it all of a sudden more and more popular?
Yeah, that's a great question. I think you're referring specifically to the NIST Special Publication 800-88, so standards for media sanitization. And these are the technical standards by which various different types of devices can be erased in such a manner that the data is unrecoverable in the future. There are different levels of it. NIST Clear erases permanently, irrecoverably, all data that is accessible to the end user. The Purge standard is the sort of highest level of data erasure, and that actually calls for accessing parts of a drive that are not typically accessible to the end user. So the significance of that is that it will erase a device or drive, a computing device of some kind, to a standard whereby the data is not recoverable even in a forensic laboratory.
So the scenario is this. Let's say I'm working for ABC agency, and I have some storage in Google. And then I decide it's too expensive and I want to go to AWS. And so I move everything to AWS. And so my question is, well, what about that stuff that's at Google, right? Is that a question people ask? Is that what's even up for consideration?
It is. It is a question that people ask. Typically, in the case of a cloud service provider, how that data is erased is tied in with their service level agreements, as you can imagine. And so a lot of that for the end customer, right, federal agency, a large enterprise, or even an individual, is based on those contractual requirements. But regardless of who calls for it and what the standard is, at some point, some storage media will typically need to be erased, and erased in a manner that is compliant with a variety of different standards and requirements. So there are, of course, security and privacy requirements that call for that. There are concerns about data security in general and confidentiality that also call for that. And so typically the organizations who are handling, in most cases, the underlying hardware, so the servers, the storage devices, as well as laptops, mobile devices are all sort of fall within this realm. There is a need. There comes a time, typically at the asset's end of life, when permanent data erasure is called for. Now, there are also times throughout the life cycle of the asset when the asset is, say, being redeployed, meaning that an employee departs and that laptop is erased and then reassigned to somebody else with a new image on it. That may be another scenario as well.
Well, I certainly have used the phrase software development lifecycle, SDLs. We all know this one, but I never thought of this part of the lifecycle. I mean, everyone talks about, maintaining the code and patching it, making sure it's secure. But what about the end of the lifecycle? What happens when Gilroy software gets replaced by some better product, Maurice software or something. And so is this part of a regular checklist that the DevSecOps people have when they transition away from an app?
I would say yes to your question about, is this something that's considered at the asset's end of life? Typically, it's not the DevSecOps folks. Typically, it's the IT asset managers. So it will fall into different realms, right? Now, there is, of course, a data security concern here as well that the InfoSec cybersecurity people will be concerned with, and they will be ensuring that the IT asset managers are, in fact, ensuring proper chain of custody and certified erasure with audit-ready evidence to ensure that it's been erased. But typically at an asset's end of life, particularly in an enterprise or federal agency scenario, the device will either be physically shredded and destroyed, or it will be reused, recycled, repurposed. And there is a whole industry called ITADs, IT asset disposition firms, that will essentially take IT assets at end of life from an enterprise or agency customer, and they will do a variety of different things with that. Essentially, what they're trying to do is recover value, and whether that value could be recovered by reselling the device, sort of complete, and it's in good enough condition to be resold into the secondary market, which is a booming market, or it may be harvested for parts. So they may determine that some parts of that device are reusable. It may be harvested for recycle material, like the actual raw material, right, that is being used to produce these devices. And then there are other scenarios where the ITAD is obligated contractually to physically shred and destroy the device. And sometimes that is because they cannot recover sufficient value from the device, and so it's not worth it to them to try to harvest or resell or recycle, or because the customer essentially demands that it be physically destroyed.
Well, I think this certificate of verification, I think this would be important to have, because I would think it would be can be loosely applied, let's say.
That's a great point, John, and that's where we see the actual technology to do erasure to a NIST standard or some other standard. There are multiple different standards, but NIST is arguably the industry standard these days. That can be performed in a number of different ways, but it's to do proper data sanitization is really three parts. You need to thoroughly erase to a standard like NIST 800-88. You need to verify that the erasure has been done for your own peace of mind, if you will. And then you need to be able to provide evidence that's been done so that you can prove it. You can prove it to auditors. You can prove it to your management. You can prove it to citizens and consumers. And so those three parts are essential for a complete data sanitization program.
Well, you got a military background, so you probably understand the logic here. I mean, so the NIST has a standard and the DoD has a standard, S220.22, something like that. So similar, parallel, how they differ?
There's been an evolution of standards over time. The DoD standard 5220 is commonly referred to. Yep, has been around for some time. The NIST standard has arguably become the de facto standard. And in fact, there's a brand new one. I say brand new, it's within the last year or so, from IEEE. And 2883 is the number associated with that standard. That is similar to NIST in the sense that it addresses media sanitization, but takes into account some of the newer technologies, right? So as storage technology has continued to develop and advance, the amount of data that can be stored on a tiny, tiny fragment of a solid state drive, for example, is much higher. And the various different means and mechanisms by which that data is accessible on a storage media has also evolved. And so IEEE is now taking into account some of those developments. It may emerge in the future as more the default standard. For now, NIST remains king.
I'm going to give you a baby example, and you can apply it to the federal government. So the baby example is Gilroy Donuts gets hit by ransomware, and I go, hey, I got backups, and I plug the backups in. And then malicious code is still there, and I get hit again for double that amount. And so the issue is what's valid, what's not valid. So you use the word data sanitization. I would think that after an organization, whether it's Gilroy Donuts or the DOD or NIH, when they get hit, there's got to be a concern about sanitization with what really happened. Okay, so we stopped the malicious code. Well, what happened in there? Is this a question that comes up in your world?
That's a great question, and it touches on where and how data sanitization can be applied in a cybersecurity context. So for much of the past 15 minutes or so, 10, 15 minutes, we've been talking about data sanitization that is tied essentially to the underlying physical infrastructure or hardware assets, right? We've been talking about servers, storage media, loose drives, laptops, phones, and so forth. But there is increasing interest and use cases related to erasure in what we could call sort of live data environments. So it has to do with the data lifecycle management. So that's another life cycle to keep track of. And in cybersecurity use cases. And what you're referring to is a scenario where as part of a post-breach, post-incident cleanup, the agency in this case will want to know that before they re-image and reuse the infrastructure that had been affected, they want to make sure they're starting with a clean slate. And so running a complete, thorough, two-standard data sanitization could very well be a way to achieve that peace of mind before the re-imaging and reuse happens.
There is a podcast in town called Feds at the Edge, and they talk about edge computing. And all of a sudden you think about the incident in Ohio, well, there's sensors on railroads. There are sensors in the ocean. There's sensors in satellites, sensors everywhere. And increasingly people are talking about computing at the edge, huh? And so compute and store, what all of a sudden it's not just a mobile phone or an iPad, it's some computer and store device, maybe in a satellite. Is that a concern, this whole compute and data store at the edge?
It is a concern. What's happening here is this is within the context of an explosion in data volume in general. So the amount of data created globally is on an exponential increase. That, I think, is intuitively obvious to everyone, but we're talking about an incredible amount of data. And that data, by the way, is not just, personal YouTube videos and cat videos on the internet and online gaming. The enterprise data sphere, right? The organizational data sphere is actually growing at twice the consumer data sphere. So as much as we are creating our own data as individuals, enterprises are creating it much faster. In fact, I saw a quote from, this is several years ago, but the federal CIO at the time, Suzette Kent, was referring to the Department of Commerce generating 20 terabytes of new data every day. I don't have a way to verify that, obviously, but if you think about what organizations are doing every day and creating data, now machines are creating data, and we can, of course, talk about artificial intelligence as well, right, where it's generating its own new unique data. That data has to go somewhere. That data has to be protected. And within that context is what I think you're referring to, which is Internet of Things. It's devices that are sensors that are kind of dumb in the sense that they're just capturing an input and passing it over the wire back. But there's also local storage and computing. If we think about set-top boxes, if we think about gaming consoles, right, for example, could capture personally identifiable information, which is protected, as we know. And so from a security and privacy standpoint, how do we address those? So as Blanco, as you can imagine, we're right in the thick of that, looking at different ways to apply standards like NIST to new types of devices.
That makes sense. I am not going to name any names here, but there was an incident with a certain political person a while back where this person had stuff on a hard drive and this person used BleachBit. And, I thought that's maybe that's a precursor to this discussion today of, oh, really? What's going on here? And so is it just a commercial application, or what exactly is this BleachBit? Is this a temporary thing?
So there are a number of file erasure or drive erasing type technologies out there of varying degrees of maturity, varying degrees of adherence to standard, and varying degrees of verifiability and provability. And so what I would recommend, without naming products either, is make sure that you use a product that can meet the three standards or the three sort of key components I mentioned earlier. It can erase to a standard like NIST 800-88 or IEEE 2883. It can verify, so it can go back and double check that it is working. And that number three, that there is a certificate of erasure, preferably a digitally signed, hard to modify, immutable record that demonstrates that that particular drive or device has been permanently erased as of that moment.
When you said the word erased, I thought of a whiteboard. I used to work with software developers all the time. We'd have, when they weren't arguing about hot sauce, we were talking about code employment, and we had this whiteboard, we'd draw things out and everything else. And, maybe we had a colo facility. It was in the early days of the cloud, but today if I was sitting in the room with you with a whiteboard, there's hybrid systems, there's dedicated, there's public cloud, there's, I don't know, where's this stuff stored, Maurice? Well, let's get out the whiteboard. It's going to change. So I think just knowing where the data is step one. And then, it could be varying levels of compliance with different storage areas. This is more than just a whiteboard solution, I think.
Very true. And you use the phrase, where is the data, and sort of hinting at the difficulties in keeping track of it. And so I would suggest, right, that beyond the need for effective data erasure, effective data sanitization, is the need to have a really solid data governance program in place in the first place. And so this is about, of course, managing data. It's also about protecting the data. So now we're talking about sort of other controls and processes, right? Data governance is only possible really if you're able to classify the data properly, ideally at the time of creation, because going back and trying to figure out what the data classification should be, there are tools that can help do that, but it's tricky, as we know. And then making sure that it's properly protected based on its level of sensitivity. So obviously classified, sensitive, protected data needs to have levels of protection that are higher than more sort of routine data. But all of that is being stored somewhere. It needs to be tracked. It needs to be properly disposed of at the end of the data lifecycle, right? When the data is no longer needed.
Better than software. Yeah, data's lifecycle. That's okay. Let's go back to Gilroy Donuts. So Gilroy Donuts gets to be pretty big. We're in 5 states. We're selling a lot of donuts. We bring in Gartner consultant. And inevitably, when they give me the deliverable, it's going to be best practice. Well, the best practice here, Maurice, and the best practice here, John. So what about best practice for good data management? I mean, are there guidelines for that? I mean, can your organization provide guidelines?
If you're referring to Blanco, I would say we have stayed true to our core competency. We focused on the data sanitization part. We also do some device diagnostics, by the way, since many of our customers are not only enterprises and federal agencies, but also the ITADs that I referred to earlier, and mobile device processors that are taking our trade-in phones and cleaning them up and moving them onto the secondary market. But we, as you might imagine, have these types of conversations with our customers routinely. And we have partnerships, I'll keep it vague at the moment, with other organizations that are part of other parts of the data management ecosystem. So if you think about the ability, for example, to properly classify or discover data, and that process includes identifying and highlighting the location of sensitive data that has now reached its end of life. So let's say files that have been preserved because of a legal hold, or must be preserved for a certain amount of time due to HIPAA regulations, right? Health records. But now, as soon as the calendar rolls one more day, now you have essentially you're liable for protecting data that you no longer need to keep. And in fact, you're required in some cases to destroy. And so you go from having to protect it and keep it alive to having to make sure that it's gone in essentially in a second. And so being able to do that properly and then be able to prove that it's been done is a key part of this whole process. So if you think about the whole data management, data governance process, data sanitization needs to be right there alongside proper data classification, data discovery, as well as data security controls, right? Encryption, for example, is arguably the primary, most sort of fundamental data security control we have today. There are some interesting future scenarios where that may become less viable. But for now, being able to tie that all together in a coherent way for the organization is really the trick. And of course, there are best practice standards. I would point back to NIST. I would, of course, point to Center for Internet Security, critical security controls as some of the places to start.
Your company is blancco.com, and was there this morning. I saw all kinds of, I never thought of being able to remotely erase data from maybe an employee's, old John Gilroy, I got to fire one of my people in the donut shop, and they walked out with a company phone, so you can remotely erase data on a phone. Well, that's kind of comforting, isn't it?
It is. It's comforting, especially for enterprise security folks, right? And so, maybe not for the employee.
Maybe not for Gilroy Donut, but maybe for, NIH.
Right. That's right. And in an era of course, remote work, particularly post-COVID pandemic in 2020, when we sort of all scattered back to our homes. That has become a major use case for our customers, actually. So it's not just the data center environment. It's also the end user compute environment. It's my laptop here. It's my mobile device that the company may have issued to me. And so rather than the enterprise IT asset manager or security team having to then ask for the employee to ship it back to some office where then they have to go in there and do all this or pass it on to an ITAD to process it, there are ways to remotely either completely erase all of the data on the device or select files and folders and virtual machines even. And so you can be fairly select about it as the enterprise, or you can be very thorough about it, depending on the use case, right? So if it is a employee exit and rehire, then of course you might want to remotely erase the laptop completely and then have them ship it back. And then you're less concerned, by the way, about that chain of custody and what's happening to all the data on the device as it's being shipped around. Or it may be a case where the enterprise says, we want to make sure that we are reducing our data attack surface, if you will. And so we are going to install a file erasure capability whereby certain types of files or the trash bin or recycle bin, for example, or temp files are completely certifiably erased on some sort of schedule or at some sort of prompt, like a restart. And that can be deployed as well. So that just sort of improves the enterprise's ability to manage the risk of data leakage and data spillage.
Well, we started off with a kind of silly opening talking about data volume and emerging technologies. So what are a handful of emerging technologies you see that can make it difficult for people to control data, especially erasing data from managing their data? We know AI is producing a lot of stuff. What else is out there?
One thing to keep an eye on, and I would say keep an eye on because there's no need to panic at the moment. But when we think about encryption as the primary data security control, encryption, of course, depends on algorithms that are sufficiently complex that modern computing would not allow an attacker to decrypt it for hundreds of years, right? Essentially making it impractical to be able to break the encryption. However, one of the concerns with emerging quantum computing is that, in fact, the capability may come into place where today's encryption standards could, in fact, be broken. And when we consider how much sensitive, classified, protected data is encrypted, that would be a game changer in terms of the risk to data. And so a couple of things. Number one, as you can imagine, there are others thinking about this problem. NIST has already been at work for several years to identify post-quantum computing standards. Now, interestingly enough, one of the standards had they had started out with 69 different algorithm candidates. And I think they're on round 4 or 5 now. But one particular algorithm had made it to round 4 and very disturbingly was essentially cracked by some mathematicians in an hour using a single core PC because they understood the math behind it and they were able to get around it. Now, it didn't make it past round 4, as you can imagine, but the fact that and another one actually was sort of dethroned in round 3 is a concern, right? In the sense that we are dependent on the strength of the algorithm to protect our data. So first of all, we need to make sure that we're keeping up with that from an encryption standpoint. But also, secondly, to think about other ways to protect the data. And this is where, obviously, my view is shaped by what I do on a day-to-day basis. But being able to reduce the data attack surface in general, meaning reduce the total amount of sensitive, classified, protected data that you need to manage as an enterprise, will help to make the problem more manageable.
Wow, out of all the interviews I've done, I've never thought of the end of life cycle, and I keep thinking of software development life cycle. But John, what about data life cycle? It's something I think has to be considered, especially with the proliferation of data from sensors. And what's it generating? Well, generative AI is generating more data, isn't it? Yeah, it's like it's almost a cycle that is just building and building and building. Unfortunately, here we're running out of time. You have been listening to the Federal Tech Podcast with John Gilroy. I'd like to thank my guest, Maurice Oanuma, who is the Vice President and General Manager Americas for Blanco Technology.
Thanks so much, John. It's been great to be with you.
Thanks for listening to the Federal Tech Podcast. If you like the Federal Tech Podcast, please support us by giving us a rating and review on Apple Podcast.